Welcome to NK Medical. Today we are going to discuss about glycolysis, and in this video we will see the definition, the importance, the site and different steps and enzymes which are involved in glycolysis, and at last we will go see the difference between aerobic and anaerobic glycolysis and understand that what is exactly mean. So first of all, let's know what is glycolysis. Simply, glycolysis is a multi-step process in which the glucose will break down into two pyruvate molecule. Glycolysis means simply the breakdown of a glucose by a multi-step process into two pyruvate molecule. And these reactions especially take place inside the cytoplasm. The glucose will going to convert into two pyruvate inside the cytoplasm of the cells. Now, in order to take place this reaction, the glucose should be transported into the cell, and the glucose is transported in the cell via two of any one transport system mechanism, which we have already discussed about this in our previous video in detail. But up right now you just understand that glucose will transport inside this into the cell via transport system mechanism, and then once if glucose entered when entered in the cytoplasm in the cell, it will go under glycolytic pathway. The main importance of this pathway is this pathway is going to release energy. This pathway occurs in order to release energy, and that released energy are going to be captured in the form of ATP and NADH. NADH itself is not a free energy molecule, but when there will be adequate supply of oxygen and in the presence of mitochondria, this NADH will go transport into the electron transport chain, and then one NADH will be going to release 3 ATP molecules. Up now, we just came to know about that. What is glycolysis? Glycolysis means simply a glucose breakdown into two pyruvate by a multiple step process, and this glycolytic pathway is occurs in the cytoplasm of the cell in order to release energy, and that released energy is going to be captured in the form of ATP and NADH. Now, what will the first, let's see the steps and enzymes of the glycolysis. The first step of glycolysis will be phosphorylation of glucose. I have already drawn here the 6 carbon itself in order to make you better understand that how is going to be phosphorylate. First step will be, this will be our first step, and in first step there will be phosphorylation of glucose in the presence of enzyme named as hexokinase and glucokinase. One of this enzyme is going to be work here in order to phosphorylate the glucose, and for phosphorylation one phosphate, I'm just making the phosphate by star, one phosphate will going to be added here on the 6th number of carbon, and that's why this named as glucose 6 phosphate. Now the question can arise here that from where this phosphate actually came from. Well, this process is going to consume one ATP and it will release ADP, and the one phosphate from here will be added on the glucose and it will become glucose 6 phosphate. Now I have indicated this arrow by red and only one direction because this is a one-way reaction. These enzymes are not going to reverse this reaction again. The next step will be conversion of a glucose 6 phosphate into fructose 6 phosphate. Fructose 6 phosphate. Now here the formula of glucose 6 phosphate and fructose 6 phosphate is same, but only there will be change in the arrangement, and this is going to take place in the presence of enzyme named phosphoglucoisomerase. And then this will be our second step, and in third step again there will be a phosphorylation again of fructose 6 phosphate. Now we already know that here is one phosphate is added already, one phosphate again going to be added on the carbon number 1, and at that time it will be, if as phosphate is added in carbon number 1, so it going to be named as, I am just writing fructose at F, fructose 1 6 bis phosphate, fructose 1 6 bis phosphate. And again this one phosphate will come from ATP and it will release ADP, and as is a phosphorylation, then again any kinase enzyme is going to work here, and the enzyme which is going to work here is phosphofructokinase 1. Phosphofructokinase 1 is going to phosphorylate the fructose 6 phosphate into fructose 1 6 bisphosphate. I am just pronouncing here the bisphosphate, even there is a 2 phosphate present here, but I am not going to pronounce diphosphate, or will not pronounce it like a biphosphate. We are pronouncing it as a bisphosphate because that 2 phosphate are not present at the adjacent carbon. There is a difference between that 2 carbons where that phosphate actually attached. That's why it's named as bisphosphate. And now the another step number 4, will going to be splitting this fructose 1 6 bisphosphate into 2 molecules which are containing 3 carbons in the presence of enzyme aldolase. Aldolase is going to help the splitting of fructose 1 6 bisphosphate, and the one molecule will be DHAP, DAP, and then dihydroacetone phosphate is already one phosphate is added here, and another it's going to be split from the middle, and another 3 carbon molecule who is containing one phosphate will known as glyceraldehyde 3 phosphate, as the phosphate is added over there in the carbon number 3, so it's named as glyceraldehyde 3 phosphate. Now this DHAP, dihydroacetone phosphate, is not going to remain the same in our cytoplasm. It will fastly convert into glyceride 3 phosphate, and this in some circumstances this glyceraldehyde 3 phosphate can also reverse and convert itself into dihydroacetone phosphate, but in most of the cases dihydroacetone phosphate is going to be converted into glyceraldehyde 3 phosphate, and the enzyme which is going to help the conversion of dihydroacetone phosphate as a glyceride 3 phosphate will be triose phosphate isomerase. Triose phosphate isomerase. Now the onward we are just going to see the one step of reaction, but we have to remember as dihydroacetone phosphate has been also changed into glyceride 3 phosphate, then actually there are present 2 molecule of this glyceride 3 phosphate, and the conversion of the DAP into glyceride phosphate is taken as step number 5. I'm going to simply write here step number 5. Now this will be the first, now there will be the first oxidation reduction reaction which is going to give us energy, and here the enzyme which is going to be work is glyceride 3 phosphate dehydrogenase, and here the one NAD is going to be taken and released NADH, and I write it with it. Now, as there is a 2 molecule of glyceride 3 phosphate, so in reality 2 NAD is going to be converted into 2 NADH, and again one phosphate itself present over here on the third number of carbon, but in number 1 carbon again one phosphate will going to be added, and this phosphate will come from organic phosphate. One organic phosphate will be added here, and that will added in this, and the name of this molecule now will be 1 3 bis phosphoglycerate. And the next step, and this step will be the step number 6, and in step number 7 again there will be phosphorylation, but there will be no phosphorylation of this molecule. There will be a phosphorylation in order to release energy. It means the phosphorylation of ADP will be done here. The 1,3-bis phosphoglycerate will convert it into simply 3-phosphoglycerate. 3-phosphoglycerate, and 1 ADP is going to be phosphorylate, and it will release ATP. And as this is again 2 molecules, not only 1 molecule is present over there, there is a 2 molecule present over there. That's why the 2 ADP is going to be phosphorylate and going to release 2 ATP in the presence of enzyme named as phosphoglycerate kinase. Phosphoglycerate kinase. And now the step number 8 will be there will be a mutase going to be work in this molecule, and simply the phosphate which is eventually present on carbon number 3 is going to be shifted on the carbon number 2 in the presence of enzyme phosphoglycerate mutase. And this molecule will name as 2-phosphoglycerate. 2-phosphoglycerate. And the next step will take place in the presence of enzyme named as enolase. The enolase enzyme is going to be convert the 2-phosphoglycerate into phosphoenol pyruvate. Phosphoenol pyruvate. And this phosphoenol pyruvate in the presence of kinases enzyme, the enzyme named pyruvate kinase, again going to phosphorylate 2 ADP into 2 ATP, and our final product of the glycolysis up to here, the pyruvate, will convert from phosphoenol pyruvate on the presence of pyruvate kinase. 2 ADP will be phosphorylate and release 2 ATP, and the pyruvate and the phosphoenol pyruvate will convert it into pyruvate. And here again I'm indicating this arrow with red because this is again a one-way reaction. This kinase enzyme is not going to reverse this reaction. This is not going to convert pyruvate again into phosphoenol pyruvate. And as we have already understand here that it will also convert into glyceride 3 phosphate, so actually there are 2 molecules are going in the reaction. So two molecule of pyruvate will present. Now let's talk about that how many energy as this process, this pathway is take place in order to release energy. Then let's talk about that how much energy have we consumed up to now and how much energy have we released up to now. In first three reaction, we have already, this reaction already consumed 2 ATP. So simply the consumed energy will be 2 ATP. And what about released energy? Then at the reaction number 6, we have released, this reaction released 2 NADH. First of all, let's talk about ATP. This is 8 step, this is step number 9, this is step number 10. Then as step number 7 and step number 8, 2 ATP released here, 2 ATP released here. In total 4 ATP has been released. So let's note it here that 4 ATP released. And also another energy molecule, the NADH, 2 NADH also has been released, and 2 NADH has been released. Now let's talk about the aerobic glycolysis and anaerobic glycolysis. When there will be presence of oxygen, adequate supply of oxygen and mitochondria in the cell, at that time the pyruvate which is broken down from glucose undergo TCA cycle, and the massive amount of energy will release. But when in the absence of, or when there will be inadequate supply of oxygen, or there will be no mitochondria present in cell, at that time the pyruvate will convert into lactate or lactic acid, and this process is going to take NADH and convert into in NAD. Then what will be the net energy, net production of energy in anaerobic glycolysis? As this 2 pyruvate will convert into lactate, so 2 NADH has been consumed again over here in anaerobic glycolysis. So the energy which we have released and we have captured, the 4 ATP and 2 NADH, the 2 NADH is going to be utilized over here in the conversion of pyruvate into lactate. So there will be only 4, now there will be only 4 ATP remains which has been released up to pyruvate, and as 2 ATP has been consumed, so we have to subtract that 2 ATP from 4 ATP, and the net energy production will be, and then 2 ATP will be remain here, then the net production, the energy production from anaerobic glycolysis will be 2 ATP. But when we talk about aerobic glycolysis, then what will be the net energy production? Let's calculate it. Once when there will be presence of oxygen and mitochondria, that NADH which we have captured will undergo in electron chain transport system, and from there one NADH will going to release 3 ATP. So as we have 2 NADH, then eventually it will release 6 ATP, and as there is 4 ATP already captured over there, so the total will be 6 ATP plus 4 ATP, 10 ATP. But we have also consumed 2 ATP, that reaction also consumed 2 ATP, so that 2 ATP should be subtract from here, and the net energy production in aerobic glycolysis will be 8 ATP. 8 ATP. That's all for today. If you like my video, then please subscribe my channel, like the video, give a feedback in the comment below, and don't forget to share with your friend. Thank you. Have a good day.